Hello, Mark Miller here. Today I'm going to get into if-then logic. What I show here can only be used inside a colon definition. Since this is a stack-based language, Boolean computation comes first, and it's followed by if. The then part is between the if and the else words, and but you can skip else if you don't want to use that logic. And the if statement is ended by then. Now this typically feels confusing to newcomers. Examples you'll read in the literature use if and then words, but you can substitute another word called end if for then because they do the same thing. I have on the screen here a couple of the Boolean operators, and it turns out these operators are bitwise. They're not logical operators, but because of the way Boolean logic and forth works, you can use them as logical and or operators. The not operator isn't defined in APX forth, but its definition is pretty simple. That's it. Also, there is a word for exclusive OR in APX forth called XOR, but it is bitwise like the others, and it doesn't work too well if you try to use it logically. So, for example, these are both true values, which logically would come out 0, but instead you get 4. And the reason for this is it's bitwise exclusive OR. So we can create logical exclusive OR like this. And this pops 2 values off the stack and pushes the result, which is non-zero if either of the input values was true. It'll come up 0 if both of the inputs were true or both were false. And I'll put up some examples of using and or. And what you'll notice here is this is the bitwise action going on, but like I said, it works just as well for logical operations. And here's an example of using if-then. I'm using it in a loop. And you'll notice another word here called leave. This exits a do loop early. And something to note is it doesn't exit the loop immediately. Instead, it sets a flag that is read by the loop word, and it causes the loop word to exit the loop rather than branching back to continue iteration. Another thing that should be noted is that leave only works with do loops. So it'll work with the loop and plus loop words, but it's not, you shouldn't use it with the other kinds of loops because it doesn't work with them. You can use a false Boolean flag with those other loops to get them to exit. And in this example, even though the loop is set up to go from 0 to 10, it exits when the index gets to 5, or actually to 4. because this is an exclusive loop. If we wanted it to be inclusive, we would do this instead. And yeah, and this illustrates the point I was making about leave, because even though the leave section is tripped in between if and then, the loop index is still printed. And this is because the loop doesn't exit until the execution reaches the loop word. And the difference between this version and the first one is that the loop index in the first version is blocked off by the else clause, and so it's not executed when loop index reaches 5. Now I'll get into arithmetic operators. Fourth supports single and double precision numbers, and single precision is 16 bits and double precision is 32 bits. And in Tom Turingham's series, he covered some of the single precision words like plus, minus, times, and divide. So I'm going to go over some more. First one is called /mod, and it pops two numbers off the stack and does an integer division and pushes the remainder and then the quotient. So you can print those out. So the quotient the quotient is at the top, so it came first, and the remainder came second. And it's important that the inputs be in a certain order on the stack. The typical way they're expected to be ordered for a word like /mod is the divisor 5 is pushed on first, followed by the dividend, which is 2. So if you wanted to say 5 divided by 2, you push on the 5 first and 2 second. Same is true with subtraction. Another operator is just a plain old modulus operator, and it just puts the remainder on the stack. Oops. All right, yep, so that was the remainder. Another one is called // and this one, there are other operators like this and forth, and they take some getting used to, because your typical programmer is not used to having combination operators like this, because what this does is it does a multiplication and then does a division on the result. So normally we'd write this out as 5 times 2 divided by 3, but you just get that end result. And this concludes, so this concludes part 3. In the next part I'll get into double precision numbers and how to do arithmetic on them, and using the hex number base, because we've been working in decimal this whole time. All right, until next time, have fun.